So we are going to go ahead and work with lesson 5 this week. So this will be our first part to the hypothesis testing unit. So we have another part next week, but we'll get started with it this week. And I know, right? Only 13 slides. I didn't realize, yeah. I'm not, yeah, maybe that does kind of, okay, I did look at that. I was kind of like, that does seem like not that much, but I don't know. Hopefully I'm not missing anything. If there's more stuff, maybe I missed something, but we'll go through these and then go ahead and see what we can do. But yeah, well, I don't know. Let's see. Yeah, how many questions do I have? I have 1, 2, 3, 4. 4 questions. I have 4 questions. I feel like, yeah, maybe I feel like there's a lot of substance to the, I know, what? We'll see. When I go through it, tell me if there's like a topic I didn't cover or something. But, so yeah, this is, let me see. I feel like there's a lot of substance in this unit, but it's important to hit on like these overarching topics, and then like specific questions will probably come from that. So that's probably why it's not as much content. I see you guys looking at the amount of slides. You're like, how long do we got to listen to her? Only 13 slides. Thank goodness. But see, technically it's only like 10 because we have my intro slide, and then we have this slide and the final slide. So we only got 10 going on. But stop me at any time, obviously, if you guys have questions. Who knows? Maybe I goofed, but I guess we'll find out, right? All right, let me just quickly review. Like I said, I always like to do these kind of reviews at the beginning to make sure that we are ready to move on with all the content. So remember, our categorical variables are what have to do with our population proportions, and quantitative have to do with population means. We did talk about this last week. Just make sure, you know, if you see a mean, that means that we are talking about some sort of quantitative variable. And if you see a proportion, that's going to be a categorical variable. So remember, proportions are going to be between 0 and 1. Always means can be anything you want them to be, basically. Just like you. You can be anything you want. I'm going crazy. All right, let's see. All right. Okay, so let's talk about, so it's important, we just talked about confidence intervals last week, so it is important to make sure we understand the difference between a confidence interval and a hypothesis test, why we would use one over the other, because they do seem very similar in reality, but we definitely want to be able to decipher between the two. So if we review from last week, confidence intervals are going to be that range of values. So remember, we got that lower range and that upper range. And that's, and then our conclusion is, do we think that the value that we're looking for, the population parameter that we're looking for, do we think it's within this range? So then we had that different confidence level. So we had, you know, we're this % confident that the value is within this range, this and that. So remember our final, you know, interpretation. We are 95% confident that the population mean or proportion is between these two values. So the main situation with that is that we are looking at this entire range from the lower bound to the upper bound, and we're saying that we're this % confident that our population parameter is within here. But in hypothesis testing, we don't have a range. We come out with one single conclusion saying, do we think that the data that we brought together is significant or not? So it's kind of like a final answer thing. We're not making like any type of causal relationships. Remember, we don't really do that when we're finding these different relationships. But we are coming to some sort of inference of whether or not the data we collected is significant or not, to basically go ahead and continue to use it for the rest of our stuff. So that's the main difference there. Okay, so this is how we would write hypotheses. So I think honestly, because I go through these kind of slow, because these are, I think hypothesis testing, it's a lot about the language that can mess people up. And, you know, because saying like, you know, that we reject and fail to reject and this and that. So to me, when I went through this unit, I really took the time to read the book and understand the language they're using, because statistics has its whole separate type of language. So I would definitely recommend using this in a way that you can understand like what they're saying, think through it, say it slowly in your head so that you understand. Sooner or later, it's going to become very automatic and you'll just understand it. But like I said, you want to have this base understanding first before you move on, or else that might get confusing. So, okay, so if we, let's get my pen up here. I haven't been using my pen. Okay, so when we're writing our hypotheses, we're always going to have our null hypotheses and an alternative. So our null hypothesis is always saying that there's no change. So if there's no change, it's going to be equal. Okay? Always going to have an equal sign. If you see a null hypothesis and there's not an equal sign, it's not a null hypothesis, or it's wrong, or something. So definitely make sure that we always have an equal sign in our null hypothesis, and then on the contrary, we are never going to have an equal sign on our alternative hypothesis. Alternative is saying that there's some sort of change going on. So, you know, it could be less than, it could be not equal to, it could be greater than. So these are like our options over here. So, yeah, the main thing to remember is that our null hypothesis is talking about no change at all. Alternative is talking about some sort of changes going on. So remember, these are always talking about, I don't know if we get into it, I don't want to get ahead of myself, but I'm just trying to think of things that I often remember students struggling with. So when we write null and alternative hypotheses, we're always going to be writing it either with mu or p, okay? Because if you recall, when we are talking about confidence intervals or hypotheses, we're making conclusions about the population, okay? Yes, that is what we're doing. We're making conclusions. So the main point here, we just want to make sure that we understand that we're making these conclusions about, this is about the population. So when we're writing these hypotheses, we're going to use the population symbols, okay? So remember, mu is our population symbol for means, and then p is for proportions. So, so remember, when we're writing hypotheses, these are based upon our populations because we're taking all those samples out, but in the end, our conclusion is going to be based upon these hypotheses. So remember, our conclusion is always an inference about the population parameter. Okay, so that's why we always have these written. So you're either going to see your null hypothesis. Technically, there's really only two ways to write it. So it's either going to be mu equals a number, and this is for a single mean. Don't worry, we'll get into like paired means and fun stuff like that. But for now, we only got one of them, so have fun with this. So, or p equals something. So here, as you can see, just as a review, we're using the population symbols for means and blah, 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 and proportions, and they're always going to have an equal sign here, okay? And then obviously the number is going to change on this side depending on what the problem is. But in this case, that is what it's going to be. So these are basically your options right now for a single mean or single proportion. And then over here, you can use any of these symbols as long as you're still using mu and p. So you're never going to see x bar, p hat. Don't put that. Don't do that. That's an easy way to trip you up. That's an easy way to like get a question wrong, is to see a null hypothesis that looks like, I'll write it in red so you know it's bad. If I put like null hypothesis, you know, doing my thing, oh, I'm going to write this great null hypothesis. I'm so excited. X bar equals 7. No, don't do it. It's always going to be either mu or p. This is what we want, okay? So we always want to have that mu or p. We never want to have our sample symbols there. So you should, if you guys don't get this, I'm trying to make sure you remember it. So, but okay, I hope everyone was good with that. I just deleted all of it. Oops. Okay. All right. Continuing on. So the main point of hypothesis testing is to decide if something is statistically significant or not. So this is what I was talking about when we were comparing confidence intervals and hypothesis testing. So in this case, if we have a hypothesis test, the whole point is to get down to the end of our test and decide is this statistically significant or not? So if it is statistically significant, like, heck yeah, that means that what we got was probably useful. We didn't do it all for naught, so it's like thumbs up to that. So if something is statistically significant, it's probably useful. And then it's showing, okay, question, only mean and proportion parameter when writing null hypothesis. And for alternative, good question. Yeah, maybe I didn't make that clear. So you're only, I'm just going to scoot back a slide. So for both of these, you're going to always use, it's either, so basically these are your options. You're going to have your null hypothesis is going to be equal mu equals or p equals. And then your alternative hypothesis can be either mu is less than something, mu is greater than something, or mu is not equal to something. Or you can have mu color, p is less than something, p is greater than something, or p is not equal to something. So these are all examples of an alternative hypothesis. So you're always going to use the population parameter for both means and proportions for both null and alternative hypotheses. Does that make sense? Okay, cool. Good question, though. Very good question. You thinking. All right, awesome. Okay, so anyway, so when we're talking about statistically significant results, it means we think there's some sort of difference in the population. So remember, when we wrote those null and alternative hypotheses, we have our null saying there's no change going on. There's null change, nothing, no. But then our alternative is saying something's going on. There's some sort of change. So if we find statistically significant, there's probably some sort of difference. So that is going to be in favor of that alternative hypothesis because our alternative hypothesis was saying there's some sort of change. So if we find a difference, that means we're in favor of that hypothesis that said there was a change. And then also just a side note that we're saying it's not from random sampling error, because if it was, that's not like that exciting. It's just saying like that was random. That, you know, doesn't really mean anything. But so it's saying our answer was useful because there's actually a difference, not just because it was, you know, random and coincidental. P-value, this is something you'll see over and over again. For me, it took a while for me to wrap my head around like what actually a p-value is. Always remember it is a proportion, so our p-value is always going to be between 0 and 1. And it's saying it's a probability. I said proportion. Our p-value is a probability between 0 and 1 always. And it's a probability that the statistic that we found, or one even more extreme, so to whatever side that we're looking at. So when we say even more extreme, let me write, so like, let's see, if we were talking about, let's say look at that normal curve. It is a good day. So let's say our alternative hypothesis was something like mu is greater than 7 or something. And let's say that here's 7 over here. My p-value is going to be this stuff going on here, okay? So our probability that the statistic or one even more extreme than that we found was randomly obtained from the population. Okay, so we're looking at a probability, okay? So it's a probability basically that what we found or one even more extreme, so to either side, if this was, you know, if I change this to like less than, you know, more extreme would mean, let's say this is -7 or something like that. More extreme for less than would be to the left. You know, it's not always, I would always get confused when I hear extreme. I'm like, whoa, extreme, like really far to the right or something. Like it just means in regards to what you're looking at. So if you're looking at greater than, it'll be farther to the right. If you're looking at less than, more extreme than to the left. So something like that. But let me clear it so it's not confusing. But yeah, so that's our p-value. Our p-value is going to be what determines our statistical significance, okay? So when we look at our p-value, you're going to get it either, you know, you'll have it on outputs and you'll see point, blah, 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 whatever. That's what you're going to use to determine if something is statistically significant or not. We always want to have a low p-value, but usually what we're going to do is going to have a threshold that's going to decide is that p-value low enough for to decide if it's statistically significant or not. So the question you've all been sitting there asking, well, Anne-Marie, like, when is it statistically significant? Let me tell you. I know, this is so exciting. So first you got to have that significance level I was just talking about. So you have to decide what level you are going to reject or fail to reject your null at. So often we're going to use alpha equals 0.05. You'll also see alpha is this too. So this is often that we see it as 0.05. This is also 5%. So yeah, we often use that. Just like what I was talking about, we often use that 95% confidence interval. It's related to that too. So that's our rejection area, basically. So we always want to have our p-value to be less than or equal to alpha. And if it is, that's when we're going to be able to say that we reject our null. So remember conditional probabilities. When we say the probability of something given, this is given something else, okay? So this is just another way to look at a p-value. So we always assume when we're doing hypothesis testing that the null is true. That's just an assumption that we make, okay? So when we make that assumption, that's basically, we base everything else off of that. So our p-value, so remember I had that definition on the last slide, the probability of it being, that statistic being that or more extreme. And then in this case, if you look at the p-value, sometimes this makes more sense to people, your p-value is also the conditional probability, or the probability of rejecting the null given that the null is true. So remember, we make this assumption that the null is true, so the assumption that there's no change, but then our p-value is the probability that we're going to reject that null given that it's true. So I won't go too far into an example, but that's like the general concept of it, that the p-value is going to be the probability that we reject that null, say there's some sort of change going on, given the fact that there is no change, because the null being true would be that there is no change. All right. That's probably why there's less slides, because I'm just talking and talking a lot. Wow, I'm sorry, guys. Okay, let's look. All right, so yeah, so if our p-value is greater than alpha, boo, we don't want this, but it happens. You'll see it often. That means we're going to fail to reject our null. So I guess it's not necessarily boo. It just means that that we're going to fail to reject the null. We didn't find anything exciting, basically, because with that assumption that the null is true, if we fail to reject it, it's saying that all the results we found didn't really tell us otherwise. You're saying, yep, you're right, no change, nothing. You took all this data, took a bunch of time out of your day, took all this data, and your p-value is greater than alpha, so still no change. So you didn't find any evidence, not statistically significant, can't conclude that there's a change, and yeah, that's that. So that second bullet, like I said again, you assume that the null is true given whatever information we have. So yeah, if our p-value is greater than alpha, so let's say our alpha level is 0.05, if our p-value is like 0.07, then we're going to fail to reject the null. So I say that very slowly in my head, fail to reject. So we are not rejecting the null. We're not rejecting the fact that there's no change. So we're assuming that the null is true. So we're still assuming, after all of our data, our conclusion is that we're assuming that there's still no change. So yeah, gotta think about that one a little bit. It's weird, but okay, cool. Ooh, review questions. Here we go. All right, so let's go through these. Okay, so in a two-tailed hypothesis about a population mean with a sample size of 100, and that's alpha. This font is funny. I thought it was cute, but apparently it doesn't like to put alpha, so. Alpha equals 0.05. The rejection region would be where? So a lot of people thought this was tricky last semester, so I'll see what you guys think. Go ahead and try to work this one out. Let me know what you think, and we will go over it. Yay. Okay, great job. Yeah, you guys are doing a great job. Where's my pen? Okay, so this answer is C. So let us discuss why. So remember when we talked about our Z usually being around 2 for a 95% confidence interval. The other thing is it's technically 1.96. We just often round it to 2. The same idea here. So if we have, our sample size isn't necessarily important in this case, so it's not really to throw you off, but it's just kind of irrelevant. If our rejection, or if our alpha is 0.05, that's like our rejection region. That's the 5%. So that means that the middle part that we're talking about, remember, our alpha is going to be the rejection region, the part that we don't, that we think is like where we would reject that null hypothesis. And so in this case, that's going to be 5%. So the center is going to be, let me draw this out. Another beautiful normal curve, courtesy of me. I'm just kidding. Okay, so here, if we have our mean of 0 here, and if our rejection region is going to be, alpha is 0.05, that means that, and this is two-tailed, so that's why I'm drawing it like this. That means that the area here plus here has to be 5% because that's our rejection region. So that means that this is going to be 2.5%. This is going to be 2.5% to add up to the 5%. Stop me at any time if what I'm doing doesn't make sense, okay? So if we have a rejection region there, that means that the center part is 95%, okay? Now remember, if we're talking about a normal curve, what are the two numbers in which 95% of the data lies within? So that's going to be plus or minus, technically 2, but we will put 1.96 for the just in the case of these numbers that we have here for these options. So this would be negative 1.96, and then this would be positive 1.96. And this comes from the empirical rule, because that's saying that 95% of the data lies within plus or minus 1.96 standard deviations of the mean. So that means that our rejection region is going to be this stuff down here. Let me go back to my other color. So our rejection region is, once again, this stuff. So that's where we get Z is less than negative 0.96. So that's going to be this area, and then Z is greater than 1.96, which is going to be this area. So that's why our answer is C. Does that make sense to everybody? Yay! All right, cool. Raise the roof. All right, let me clear my drawing. Alrighty, let's do another one. Okay, so this just makes me laugh. Okay, a researcher claimed that feeding cows a half a pound of bananas every day will help them to lose 8.5 pounds after 1 month of treatment. If we want to conduct an experiment to determine if the cows are losing less weight than advertised, which of the following hypotheses should be used? Oh, these M's should be Muse. I'm never using a cute font again. Okay, this is Mew. Okay, just so you know, all these little things are Muse. Okay, so go ahead, try this one. Let me know what you think. Okay, good. So yeah, let's review this one. Good job. So our answer is C. Awesome job. Okay, so remember, when we're looking at this, if we go through these, first of all, remember our null hypothesis has to have an equal sign in it. So D and E are already out because our null hypothesis has a not equal to sign. So that's no bueno. So that's done. B can't be correct because our alternative cannot have an equal sign in it. So that's not good either. And then for A, the only issue with that is that if we look at our actual problem, it says determine if the cows are losing less weight than advertised. So that's going to be our alternative hypothesis, the less weight. And the weight advertised would be the 8.5 pounds. So that's why C is the correct answer, because it's saying that mu is less than 8.5. So C is correct. A is saying that mu is greater than, but our alternative should be less. So that's why A is not correct. So our answer is C. Does that make sense to everybody? Yay! All right, good job. You guys are very smart. Smarter than me when I was in Stat 200. All right, let's do another one. Okay, so, all right. Hypothesis test is done in which the alternative hypothesis is that more than 10%, wait, yeah, sorry, the screen was weird. Okay, more than 10% of a population is left-handed. The p-value for the test is calculated to be 0.25. Which statement is correct? All right, great job, guys. Absolutely. So our answer is D. So if we look at this, we can see, so we have our hypothesis done, and the alternative is that more than 10% of the population is left-handed. So if we actually wrote that out, I don't like that color, it's going to be that our alternative is going to be P is greater than 0.1. So that's saying more than 10% of the population is left-handed. So we have our p-value, which is 0.25. So really, any type of rejection, depending what alpha is, usually like the largest we even use is 0.05. So assuming that it is 0.05, you can always kind of assume it is if we're not given it. Our p-value here is greater than our is greater than alpha. Sorry, that took me a second. Is greater than alpha. So in that case, that means that we're going to fail to reject the null. And our null would be that that 10% of the population is left-handed, so p equals 0.1. Okay, so in this case, we're failing to reject the null, so we're still assuming that this is true. So in this case, we're assuming that there's no change, so D has to be the correct answer because it's the only one saying that we can't conclude that, and then this technically is the alternative hypothesis. You know, this entire saying right here. So we cannot conclude that we agree with the null hypothesis. We're in favor of the we cannot conclude that we agree with the alternative. We're in favor of the null. So that's D is the only one saying that. This 25%, these aren't correct because the 0.25 is our p-value, not our not the value we're using with our null and alternative. And then A isn't correct because it's saying we can conclude that, but that's not true because we failed to reject the null. So D is the correct answer. Woohoo! All right, last one. Sad. Okay, this is a quick one. True or false? If P is greater than alpha, we reject the null hypothesis. It's kind of trying to drive that point home, I think. So. Okay, great. So yeah, Hannah, you're definitely right. So we do fail to reject if our p-value is greater than alpha, like we just did in the last one. Fail to reject the null. So this is false because that's not true. So this is actually true one down here. So p-value greater than alpha, we're going to fail to reject the null. We're assuming that there's no change in that case. So, all right, good job, guys. You did a great job with that stuff. Okay, so that's all the reviews I have for tonight, I guess nighttime. So obviously, once again, you can watch back these super riveting videos on YouTube, and our next group review will be for this same chapter on Sunday, the 24th at 10 o'clock. If you haven't given me your Penn State email, go ahead and do that for me. If you have any questions, go ahead and type them into the chat box. If not, that's a wrap. Bye. Yep, have a good night, guys.